In 10.2, we're going to learn about circles, and more importantly, we're going to learn about arcs. So first we're going to talk about the central angle of a circle. And the central angle of a circle is an angle that forms in a circle where the vertex is at the center of the circle. So notice that you have this radius here, and you have this radius here, and both of them end on the circle, and they create this central angle right here. So angle ABC is a central angle, okay? So again, an angle whose vertex is in the center is considered a central angle. Go back. What happens is when you create this angle, what you're going to notice is all of a sudden your circle now has kind of been broken, right? You have this piece here, which is arc AC, and then you have this larger arc that also goes from point A to point C, but notice it goes in the other direction. It's obviously bigger. So we're going to now look at that and say, okay, well, what are these arcs called? How do we name them? What do they mean? Now, what happens is when you create, so like I said in the last slide, an arc is a broken part of the circle. A minor arc is an arc less than half the circle. So in other words, a minor arc is less than 180 degrees, okay? And when you name it using 2 points, okay? 2 points, basically the starting point and the ending point of it. A semicircle is an arc that takes up half of the circle. In other words, it equals 180 degrees, and you name it with 3 points. And I'll show you what I mean. And a major arc is an arc greater than half the circle, or in degree measures, it means it's greater than 180 degrees. And again, you also name it with 3 points. So in this circle, we're going to notice that DC is stated as the diameter. If DC is stated as the diameter, then we know that B is the center of this circle. And so if B is the center, we know that any angles formed with the center as the vertex, for example, this angle here, angle ABC, that vertex there is going to be a central angle. Now, if you notice that angle ABC creates this arc here. It breaks the circle into this piece. Well, this arc, AC, is a minor arc. And again, we know it's a minor arc because it's less than 180 degrees. How do I know it's less than 180? Well, because you're going to learn something in the next one, but just know that 180 degrees is a half circle, and so this is clearly less than a half circle, okay? When we go to the next arc that's formed, let's look here. It says arc DAC is a semicircle. So D is your starting point, C is your ending point, and the A means it goes through A. So the arc goes from D to C through A. If we didn't label this middle letter A, we wouldn't really know, is it this way or is it this way? And so that's really the goal of the 3 letters, is telling you which direction. And so DAC is that way, and again, notice that the central angle would be this, which is a half circle, which is 180 degrees, which makes sense because arc DAC is a semicircle or half a circle. And the last one there is arc ADC. Notice that A to D all the way to C, and notice that that's more than half a circle, and so we know that it's greater than 180 degrees. So this one would be less than 180. And so again, we have our arc name. Anything less than 180 is described with 2 letters. Anything 180 or more is described with 3 letters. So here we know we're looking at the measure of an arc. Well, the measure of an arc is equal to the measure of its central angle. This is specific to when we have a central angle, right? When the vertex of the angle is at the center. So if this central angle here is 50 degrees, then I know that arc AC is also equal to 50 degrees. Now, arcs are interesting because they have a degree measure and they also have a length. Like this arc A to C is going to have some kind of a length, right? It's going to be 2 units long, 2.5 units long, whatever. But it also has a degree measure. And when we're talking here about measure of an arc, we're talking about its degree measure, okay? So the degree measure is going to match the central angle that kind of created it. So the measure of arc AC is 50 degrees. Let's look at the next one here. The next example says, what is the measure of arc CAD? So again, from C through A all the way to D. And you recognize, oh, that's a half circle. So that's going to be 180 degrees because a half circle has a measure of 180 degrees. So what I might do when I come across a problem like this, before I even start it, I might kind of figure out all my pieces. Like this piece is 130, this whole side is 180, and again, just to kind of guide me for the other questions I might get asked. The next one says arc measure ACD. So again, I start at A, I go through C, and I go all the way to D. So I'm like, okay, well, A to C is 50 degrees and C to D is 180. So 180 plus 50 is going to be 230 degrees. So those would be my measures if I asked you what kind of arcs. The first one is a minor, the other one is a semicircle, and the last one is a major arc, because again, it's greater than 180. So somebody says, well, what are adjacent arcs? Well, adjacent arcs are arcs that are next to each other that share exactly one arc point. So for example, notice here's arc TQ and here's arc QR, and notice that those two arcs touch in one spot at point Q. So those would be adjacent arcs. Something like TQ and SR are not adjacent because they don't touch anywhere, okay? And if I had, like, let's say SR and then I had another arc like this, well, these would not be adjacent either because these touch in multiple spots. All these overlapping lines are points that touch. So again, adjacent arcs touch in one spot. So here we're going to talk about this arc addition postulate. And this is very similar to angle addition postulate and segment addition postulate that you guys learned in the very early chapters. And basically it says that the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So for example, what it's saying here is that the measure of arc ABC, so ABC starts at A, goes to B, and to C, this large green arc is going to be equivalent to this red arc here plus this blue arc here. Those two pieces add up to the whole. So you've done this before, and it makes total sense that what this postulate is saying. And the next one that we're going to talk about is congruent circles theorem. So what this is talking about is, how do we know that two circles are congruent? Well, we know two circles are congruent if and only if they have the same radius. So if we know they're congruent, we know their radiuses are the same. And if we know the radiuses are the same, then we know that they're congruent. Okay, so we can use that if and only if, that biconditional statement, interchangeably. So here we've got the question now about congruent arcs. So if we want to know if two arcs are congruent, that means that two arcs are the same size. That's going to be a little bit different. Two arcs are the same size if they have the same measure and they are arcs of the same circle or of congruent circles. So if they have the same degree measure, yes. And they have to either be on the same circle or congruent circles. And I'll show you what we mean by this. Because let's say we have a circle here with a radius of 3. And we create an arc that's 90 degrees. So this arc is 90 degrees, right? That would be the measure of that. Now I could have a bigger circle that also creates a central angle of 90 degrees, and this arc is also going to be 90 degrees. However, is that arc the same? Is that equivalent? Well, degree-wise, it's equivalent, but if I did length, the length of this little arc here is not the same as the length of this arc, and the reason is because the circles are different. The radiuses are different. This is a larger circle, and therefore that piece is going to be longer. So the only way that arcs are congruent is if they're either on the same circle with the same size, like in other words, here's another 90 degree. Well, this arc here is going to be the same size as the other one because it's the same circle. Or if I happen to have it on another circle that is exactly the same size, okay? So again, you have to consider for arcs to be the same, to be congruent, they have to have the same degree measure, but they also have to have the same length. And the only way they're going to have the same length is if they're on the same circle or a circle of the same size with the same radius. Now let's work some problems out. Oh, there's still another theorem. Wow. So this last one says congruent central angles theorem. Congruent central angles theorem. So we're talking about central angles that happen to be equal. So it says if you happen to have, you're either in the same circle or in a congruent circle. In other words, one circle or two same-sized circles. Two minor arcs are going to be congruent if and only if their corresponding central angles are congruent. So what we're saying is that arc BC will only be equal to arc DE if this central angle here is the same as this one, and vice versa, right? These two angles are only going to be equal if their arcs are equal, okay? So let's try to do some problems with all these theorems to practice it. Let me go back to this one last slide. It's similar circles theorem, and it basically says that all circles are similar. They are. All circles are similar because they all have the same shape, right? They can be different. You know, remember we talked about it. Similar shapes can have different sizes, and so circles fall under that same category. So circles are similar. Now, two arcs are similar. If I'm trying to figure out if arcs are similar, the only way that arcs are going to be similar is if and only if they have the same measure. And by measure, I mean degree. So arcs can be similar as long as they have the same degree measure. To be congruent, they have to have the same length as well. But to be similar, they just have to have the same degree. Just kind of keep going. I want to go to like some practice problems. We'll go back to that other slide in a minute, but we've learned a lot and I want to do a little bit of practice with what we've learned. So first example here, it says, let's name two minor arcs. So again, I look at this circle, the center is 0. So for example, this angle here is less than 180, which means this arc here, RC, is going to be less than 180. So arc RC is going to be one minor arc. I also see this angle is less than 180, so I know that arc RA is also going to be less than 180, so it's going to be a minor arc. Keep going to the next one, right? It says, okay, what are two major arcs? Okay, well again, major means greater than 180 degrees. So I might start at R, and I might go through C, and I may go all the way to A. That's definitely a major arc. So RCA is one major arc. I might do, for example, I might want to start at R this way, and I might want to do from R to A to C, right? So I might do RAC, that's another one. I may want to start at A. Maybe I want to start at A here, and maybe I want to do ACR. So ACR, okay? Or whatever. So again, as long as I know that a major arc is greater than 180 degrees and I need to name it with 3 letters, I'm going to get the right answer here. 2 semicircles. So one semicircle, maybe I start at A, I go through R, and I go to C. So ARC is one semicircle. And maybe I want to start at A and I want to go this way through point D here. So ADC. And that would be a semicircle. An acute central angle. So again, now we're going back to angles instead, right? So if I'm going to angles, I know again that if this is a minor arc, I know that this is an acute angle, right? So I can name this angle. This is angle AOR or ROA. Remember that the center is going to be the middle letter, right? And then that's the only one they asked me for. So, I mean, another one I could have written was I could have done this one. I could have done angle ROC, which is also angle COR, depending on the order of the letters. And then the last one is 2 congruent arcs. So again, for congruent, I would have probably stuck with the semicircles, right? I think the semicircles are easy to make 2 congruent arcs. I know that ARC is going to be equal to ADC because both of them are semicircles, and so both of them are equal to 180 degrees. Last question here that again, let's just kind of keep answering some questions here about these arcs. Let's utilize some of these things that we've learned. So the first thing it says is give the measure of each angle or arc. So first of all, I'm going to look at this, and this is just kind of how I do my math, and again, you can do it differently, but for example, I know that arc WT is equal to 50 degrees, which means the central angle is equal to that. It's also 50. I also know that this line here, YT, goes through the center at O. So I know this half here is 180 degrees, right? I also know that this half has to add up to 180. So if one piece is 30 and one is 50, the other one has to be 100. And so I've kind of filled in some of these missing pieces. Now again, let me kind of do it a little bit neater. But I know like this is 100. And so when it says WX, the arc, well, I know that WX is from here to here, and it goes with this central angle that I kind of already identified as being 100 degrees. So the measure of it is 100 degrees because it matches the central angle. Then it says angle WOT. Well, WOT is this angle here. And again, I know this angle matches the arc measure. So this has to be 50 degrees as well. I'm going to keep going. Then it says, all right, what is arc XYT? So from X to Y to T. And so I'm like, okay, XYT, well, X to Y is 30, and Y to T is 180 degrees. And so now I'm going to use my arc addition postulate. I know XYT is going to be the sum of 30 plus 180, or 210 degrees. Because again, these two arcs are adjacent. And then my last one, let me just kind of erase, right? My last one wants to know what is angle YOT. So from Y to O to T, that's this. Well, that's a semicircle or a half circle, and that's 180 degrees. And so again, we used our angle addition postulate here. We also used the fact that we know that the central angle and the arc measure are the same. And let me just go back then to that one